Stamitalks.
Hello and welcome. My name is Chantal Spies and you're listening to Stamitalks. Now, in today's episode, I'm lucky enough to have two of our most celebrated engineers with me. We have Muñoz and we have Carmen Pérez, and they will be telling us more about nitric acid technology. Now, Carmen, I've heard that you've been working with nitric acid technology for almost 4 years, and you have been working with this technology for over 8 years. So, firstly, I'd like to say welcome for being here today and for sharing your knowledge with us. I'm looking forward to having this conversation with you. So thank you for joining me. But now, just to kick off this podcast quite casually, maybe the two of you can tell me a little bit more about your experience with this technology the past couple of years.
Yeah, we can start. First of all, thanks for having us here. I think we both love talking about nitric acid, so we are happy to share our experience with you. From my side, I started at Stamitalks 9 years ago, and then 1 year after, I started to become part of the nitric acid team. It has been a very interesting moment because it was when Stamitalks decided to relaunch the nitric acid technology to the market.
Okay, so this is actually a relaunch technology.
Yes, that's right. Stamitalks licensed nitric acid in the past, so between 60s and 80s, around 40 nitric acid plants were licensed by Stamitalks. But afterwards, for strategic reasons, Stamitalks decided to stop this business, and then it continued with urea. But in 2016, the company decided to extend the portfolio. And to do that, the most logical way was to go to adjacent technologies to urea. And then it was when we decided to relaunch the nitric acid technology.
Okay, so, that makes sense. And I'm glad that you did that. Otherwise, the two of you wouldn't have been having this nice conversation with me today.
Yeah. So it's the way we did that. The last plant that Stamitalks licensed was a dual pressure plant located very close to our office. So it's a plant owned by OCI Nitrogen. So we took that plant as our reference plant. And of course, we needed to upgrade the design to bring it up to the current standards. And that became our standard dual pressure technology nowadays. So
okay, and you were part of the upgrading process, I presume. That was your main responsibility at the time. Okay.
Yeah.
Oh, very nice. And you, Carmen?
Yeah, hello. Thank you very much for having us here. I started in Stamitalks 4 years ago, and as a process engineer, and the journey has been very interesting because I think for a process engineer it's like a very nice job. You get to do a bit of everything, not only process design, but also a bit of communicating with sales, suppliers, and there are a lot of parties involved in the nitric acid technology. And when I started, they were developing the dual pressure technology, as Paz mentioned, because that is the technology in our reference plant. And at that time, we started with monopressure. We will talk about the differences, I think, a bit later. But this is because we were seeing that the market was asking for lower capacities. And that is where we decided to go for monopressure technology. And I was taking part of this development.
Okay, well, it sounds like the two of you have definitely not been bored the past couple of years.
Not at all.
And I've also seen and heard that the two of you have been attending conferences, giving presentations, and I've noticed on LinkedIn that whenever the two of you give a presentation, like the compliments are just like streaming in, congratulating you on a job well done. But now I want to know, what has like the reaction been to your presentations at conferences? What was the overall feeling? Like, did people give you feedback afterwards? Were they excited about this technology, interested? Did they maybe have a couple of concerns?
This year Carmen gave 2 presentations in nitrogen and syngas conferences. I also gave a presentation in the ANA conference this year in Bulgaria. And then I think in both cases the reactions were very positive. I think the clients are happy that we are also there in the market offering our technology. And then, we have nice features of it. So people are really interested in what we are offering.
Yeah, our technology is different to other technologies in the market, and also we see that there are a lot of participants in the conference that are also producers that have all the Stamicarbon plants. So I think it is interesting for them to see that we are back in the field and that they can come to us for solving problems in their plants or asking for information or revamp studies. So I think for producers it's good to have us there.
Okay, so overall, like a positive reaction.
Yeah.
Okay,
Yep.
and I have to say also from my side, compliments for doing such a good job. It makes us proud to see the two of you shine on the stages at conferences.
Thank you.
But now I just want to circle back to something the two of you said during the beginning of your, when you gave your introduction. So you speak about both dual pressure technology and also monopressure technology. And Carmen, you also mentioned that the nitric acid technology is different to other nitric acid technologies. So maybe this will be linked to the question that I have. Say, for example, there's a plant manager standing in front of you, or maybe a possible investor thinking about investing in this technology. When would you advise this person to go for monopressure technology and when to go for dual pressure? Like, what are the benefits of going for monopressure and what are the benefits of going for dual pressure?
Yeah, the main differentiator of mono and dual pressure is the capacity. So if this person wants to go for a large capacity, he should go or she should go for dual pressure. But if we are talking about small capacities, it is better to go for monopressure. And that is because the process, in the dual pressure process, it takes the oxidation takes place at the optimal pressure and the absorption takes place at the optimal pressure. And these are the two main steps of the nitric acid production. So in the case of a monopressure, these two steps take place at the same pressure, and that is what the efficiency of the process is compromised. But on the other hand, the capex, the total capital cost, is lower as well. So if the driver for going to this project is the capex, to reduce the capex and the capacity is low, that person should go for monopressure. If we are looking to maximize the efficiency of the process, then the design is more sophisticated, so the investment is higher, but the operational cost will be lower. And then, that is the dual pressure technology.
Okay, well, thank you for giving that comparison between the two. And I just want to stick to the a more technical side of this topic. Now, on the webpage of nitric acid, it says in big bold letters that this design has the lowest energy consumption. Now, firstly, is that indeed true? And if so, what is the secret sauce here? How do you make that happen?
We can say that we have a very good heat integration in the process, and then maybe I can start a little bit from the beginning. So for producing nitric acid, we need air and we need ammonia. The oxygen from the air is consumed, and the nitrogen is just an inert that goes through the plant, and at some point this nitrogen starts to be called tail gas. So you will hear us a few times talking about tail gas. This is basically the nitrogen that comes along with the air. In our process, we are able to heat this tail gas to a higher temperature than competitors, than other conventional processes. So this, by heating this tail gas, we are able to extract more power in the expander, because this tail gas has 10 bar temperature in in dual pressure. And then in monopressure, it's around 7 bar. It's depressurized, so the hotter it is, the more power we can extract from it. So by doing that, we are allowed to export more steam in our processes, so both in dual and monopressure, than in a conventional nitric acid plant.
Okay, and you talk about you can reach higher temperatures by using this unique design. Does this also eliminate the need for natural gas to a certain extent or not?
Yes, right. Actually, we are able to heat this tail gas to higher temperature because it's located closer to the platinum gases where the temperature is very high. So we reach 480 degrees there. After this step, we need to remove N2O, that it's a contaminant that it's in the tail gas, only in ppms, 1000 ppm, but we need to eliminate N2O because it's a huge contaminant, huge contributor to the greenhouse effect. So we do it in a tertiary abatement reactor where N2O and NOx are eliminated at the same time in two different catalyst beds. But with this high temperature allows for the reduction of N2O without adding natural gas. Oh. So that's also a big advantage of our process.
Definitely. Now, sticking to the environmental side of things, we've just spoken about the energy consumption side of this design. What about emissions? Do you have ambitions for reducing emissions with the design? What is the current status on that?
Yeah, we are offering base available technologies in reducing emissions. We have now the proprietary tertiary abatement system by Stamicarbon. And with that, in one reactor, we can combine the reduction of N2O, that is what Paz just mentioned, only by thermal decomposition without adding any reducing agent. And then also the reduction of NOx, that is another contaminant that is in the tail gas. So in one reactor, we can remove both impurities and we can deal with the most stringent legislation nowadays.
Oh, that's actually very good news. And is this something that's unique to this design?
Yeah, it is not unique because there are I think nowadays everyone needs to adapt their plants to reduce the emissions. But it is something that we are seeing more and more, and old plants will need to have this device as well in the process, because now the legislation is becoming more stringent everywhere. So all around the globe we are being contacted for implementing this item in existing plants. And we have a tailor-made design, so we can make it adapt to every plant, and we can also play with integration to avoid the need of natural gas. And as we mentioned, we are adapting our design for every plant, every specific case.
So what you're saying, this is not just like a cookie cutter design. You really sit with the client and you come up with a tailor-made design that's perfectly suited to their needs.
Yeah.
Okay.
Yeah.
So, Paz, you mentioned earlier that obviously ammonia is needed to produce nitric acid. Now, a couple of weeks ago, I had a conversation with Mauricio about a green ammonia design. Is there any possibility to synergize these two designs, or is that something that we're going to look at in the future?
No, in fact, there are many possibilities to do synergies between both technologies. We are happy that Stamicarbon acquired green ammonia, because having both technologies in-house makes us, or facilitates us, the way to integrate both technologies. As it was mentioned 2 weeks ago with Mauricio, for producing green ammonia, where you need electrolyzers to produce the hydrogen, and you need air separation units to separate nitrogen from the air. And one of the byproducts there is oxygen. And then oxygen can be of very good use in the nitric acid plant, because actually we are using the oxygen coming from the air. But if we could have pure oxygen, then we could reduce the amount of air sent to the plant. So lately we are being focused on developing different processes to reuse this oxygen, and this brings a lot of advantages to the nitric acid design.
Okay. Yeah, it looks very promising. And actually we see also more and more projects, as we mentioned at the beginning, that require monopressor technology, because usually the green ammonia is linked to small capacities. And these green nitrate complex are very interesting in remote areas where there is no access to natural gas to produce gray ammonia. So people tend to go more for small plants, green concept, and the whole complex like that. Yeah.
Yes, obviously, like making technology greener, and we spoke about the emission reductions earlier on. Like you're saying, like the regulations are becoming stricter and stricter. So it's very important to take these things into consideration. But it's also nice to hear that you haven't been standing still. You've been, just going forth, adding more designs and more technologies, which is very, very good to hear. And I can also presume that as engineers, that's quite nice. Constantly being challenged, constantly coming up with these new
Actually,
ideas.
I would say that the nitric acid business is a little bit conservative. So now by combining these technologies, we are allowed to find new ways of integration, and that's I think that makes our life funnier.
Yeah.
Yes. Oh, no, that's very, very good to hear. I can also see on your faces you're both smiling. I can really tell that this is something
we
you're
like
quite,
a lot the topic of green ammonia integration.
Yes, that is nice. Yes, and that's definitely the future. And it's also good to feel that you are part of future technologies, right? So that's something you can put your name on and say, listen, I was part of the green transition, which is a wonderful thing to do, I can presume, for an engineer. But now I can also imagine, so we're talking about all the benefits, and both of you look excited to work, to work on this project. But I can also imagine if somebody is a plant owner, or we spoke about possible investors, you might be a little bit scared to invest in a technology that hasn't been tried and trusted. Have we implemented this technology already? What is the status currently? Are there people making use of it? You said obviously before the relaunch in 2017, many other nitric acid plants were launched a few decades earlier. But what is the current status? So what references are we looking at the moment?
Yeah, we are in the way of implementing it.
Oh,
it's true that it is a very competitive market, and there are a lot of competitors with references, in the last years, not like us, because, we were stopped. But now we are in the way of implementing nitric acid for the first time back.
And congratulations.
Yeah,
that must be
thank you.
quite exciting. Well done.
Yeah, we prepared our first PDP last year, and it is in a nitrate complex. So we are Stamicarbon is offering nitric acid, but also urea is part of the complex, and green ammonia, and for the first time also ammonium nitrate.
Oh, okay. And can you tell me a little bit more about that? Because I presume this is an entire production unit, and so you're also responsible for the ammonium nitrate part of that. That's also part of your business line, correct?
Yeah. Mm-hmm. Yeah. There, the nitric acid plant is monopressure, is one of these green concepts that we mentioned before. And it is nice that everything is under the umbrella of Stamicarbon, because it gives us room to integrate streams, as we mentioned, the integration with green ammonia, but also with ammonium nitrate and the connections with urea. So for us, it is a very interesting project, and also in order to cooperate as a team with other colleagues in Stamicarbon. Yeah.
Yes, because you have these cross, you're working cross team basically. So you also work with other teams, you work with the urea engineers. So I'm guessing that must be quite fun, also working with other types of technologies and then bringing all of that together to work, as a synergy, correct?
Yes. Yeah.
Okay, very, very nice. Now, Carmen, you just mentioned that this is quite a competitive technology, but why did this specific client chose to go for your nitric acid technology? What do you think were their reasoning behind choosing this technology? Is it the knowledge that you have? Is it purely the benefits of the technology? What do you think was their main reason for choosing to work with you and your team?
Yeah, I think maybe it's because in this project, urea was also involved, and in the urea we have a lot of references as Stamicarbon, and it is widely recognized. So when we work together with urea, it makes it easier for us to be selected, and I think that is one of the main reasons. So for us, it's a big opportunity.
I think also here the final product is urean. So you need to mix urea solution, ammonium nitrate solution, and also DEF, right?
Yeah.
There is also a small production of DEF. And I think also one of the main reasons to select Stamicarbon is that we can provide the full technology portfolio. So also towards the client that makes the selection easier, because you only need to talk to one licensor, not to 3 or 4.
So like a one-stop shop, and then the client can have this entire production unit with say one point of contact, and then integrate all these different technologies. Yeah, I can imagine that must be a lot easier than, speaking to several different designs and project managers.
Yeah.
And what is the current status of this project?
Yeah, we prepared the PDP last year, and now it's on the hands of the contractor. So now the contractor is working on it, and we hope it progresses fast.
Okay.
Yeah, do you know the year where it's supposed to be 2026?
That sounds familiar, but
Yeah.
I'm not
So
sure.
we hope in coming years we have it running.
Okay, 2026, fingers crossed that the plant will then be up and running. So will that be your first nitric acid startup that you have to do? Oh, that's very exciting.
In Nebraska.
Yeah, in Nebraska, out of all places. How lovely. I can imagine it will be quite exciting for a process engineer to be part of a startup project.
Yeah.
And I'm sure, looking how competent the two of you are, that it will go really, really well. So now I just want to know, what are your ambitions for the future? Do you have ambitions for this technology in the future? What are you hoping this technology would look like, say, 10 years from now? What are you hoping to accomplish yourselves, but also the vision for this technology in the future?
Yeah, I would say that is what we mentioned before. We are very focused on green nitric acid, as we call it. So integrating with other technologies, low emissions, high energy efficiency. So we are now working. We have some innovation projects in the pipeline. Looking towards this direction. So we see a very positive future for nitric acid, especially when combining with green ammonia. The way to nitrates makes more sense for producing fertilizers. So I think we are convinced that there is a wonderful future for the nitric acid.
Okay, happy to hear. I guess Carmen is nodding her head, so it looks like she's agreeing with what you're saying. Saying
of course. Yeah.
So we've touched on many different elements. We spoke of your experience, like the difference between mono dual pressure, also how it can be integrated with other technologies, as you already mentioned, like ammonium nitrate that you were responsible for as well. And we also spoke about, the possibilities on how to create synergy between green ammonia technology. So we covered quite a lot of topics during the podcast. But just to end it off, and maybe there's a bit of a risky question, but what has been your biggest challenge working on this project, but also the highlight? So what is your biggest highlight, and what has been the biggest challenge working on this project?
This is a difficult question.
Yeah.
You start?
Yeah, I don't know. Maybe the biggest challenge most likely was to prepare the PDP, I think, for this first project. And there for us it was the first time doing it. So it was very nice that we had support from our colleagues from Urea that are much more experienced than us on this. But on the other hand, it made us learn a lot. And now for future projects, we are more than ready. So that is,
So many sleepless nights and a little bit of stress, but it looks like it all turned out pretty well.
Let's hope so.
Okay.
I think from my side, I would say that the main challenge is being commercializing the technology. So as you said, our references come from years ago. So it's been difficult to bring this technology back to the market. Now we have already one project sold. So once this reference is running, then it will be easier. But that has been challenging during the last years. And about highlights, I think lately we are. From my side, we are having the most interesting period where we are trying to find new ways, new concepts that can be adapted to the current and the future needs of the market. So
Yeah, I think what you also said earlier, what is I think a benefit of the two of you and your team is you mentioned that nitric acid is quite a conservative industry. But even though it is a conservative industry, you're still thinking about the future. You're still thinking about, integrating it with, green ammonia technology. You think about emission reduction. So it sounds like you're doing a good job. It sounds like you're excited. And it's also good to see that you're not just, sticking to what you know, but you're also thinking further ahead than, the present times. And I think that is, for me, just to speak to the two of you, it's very inspiring to also hear the work, what you've done, and also to see how ambitious you are and that you still have that excitement even though you've been working with this technology for 8 years plus and Carmen, you for almost 4 years. Like I said, already said this before, but you two are smiling, you have, very positivity in your voice. So I'm sure, you have many good things to look forward to. So on that positive note, I would like to thank the two of you. Pas, Carmen, thank you so much for joining us on this episode of Stamitalks. Thank you for being here, sharing your knowledge. I really enjoyed chatting to the two of you. So, and with that being said, also to the listeners, thank you for tuning in. And we hope that you will listen to some of our other podcasts. Please keep an eye on our LinkedIn, where we will be sharing information about future podcasts and also conferences. So thank you so much. Take care and keep well. Goodbye.
Thank you.
Bye.
Bye.
Thank you.
Stamitalks.